Hello, ladies and gentlemen. This is Mr. Benzel here, and today we're going to discuss our first skill of geometry in CCR, which will be focused on angle pier problems. So if you're taking geometry, you're going to find this really helpful as you study for your final exams. So what we're going to do first is just review some angle pairs. So I'm going to draw some pictures of what those angle pairs look like. So the first angle pair we have is a vertical angle. And the vertical angles, they share the same vertex. And they are congruent, meaning that they are the same shape and same size. So we set them equal to each other. And then a linear pair, this is going to be kind of like the most common supplementary angle type of situation. So if we notice this angle and this angle make a semicircle, which is 180 degrees. So a linear pair are two angles that are supplementary that add to 180 degrees, and they are next to each other. Additionally, what you may see on the SAT sometimes are these linear triple type of things as well, which are like the linear pair, except they're not two angles. Instead, they are three angles, like that. And then bisector, bi means two. So this is two pieces or two sections, and they are equal pieces. They are congruent to each other. So a segment, line, or ray that cuts an angle exactly in half. So two equal pieces. So what that means is I may have an angle like that and a bisector that cuts it evenly in half. So maybe if this is like 120 degrees, then that means that this angle has to be 60 and this angle has to be 60 as well. So those are your basic angle pairs that are centered around kind of one intersection. What we're also going to see are angle pairs that deal with parallel lines because they make up other shapes as well, especially things like networks of triangles or parallelograms. So the first is the alternate interior angle. So that looks like this. And the alternate interior angle, sometimes you may see them in the context of a triangle type of situation like that as well. So I included that picture so you can kind of see what they look like maybe outside of your basic diagram. So these are congruent. Set them equal to each other. And they are inside the parallel lines on the opposite sides of the transversal. And the transversal is just that diagonal line that goes between the parallel lines. The alternate interior is the same idea as alternate interior, except we are going to be looking outside of the parallel lines. So the written definition is almost the same, so still going to be congruent. And then instead of inside, I'm going to say outside the parallel lines on the opposite sides of the transversal. The corresponding angles are also congruent as well. And they are same relative location to the intersection. So what I mean by that is, let's say I have that conventional diagram there. So if this is kind of like on the northwest corner, I need to be looking at the other northwest corner as well. And then the same side interior angles are the ones that are not congruent. So this angle is acute. And this angle is usually going to be obtuse. Now, I say usually because sometimes you could have, 90 degrees and have both of them be right. But these are angles that are same size, side, inside of parallel lines. And you add the two angles to 180. So these are the angle pairs that are useful to know for the SAT before we get into things like the triangles and the quads. Take a minute to copy those down. Make sure you have a good grasp of what they look like, as well as the written definition and pointers on how to set them up. I like looking at the SAT problem and the Delta math problem, or I should say conventional geometry problem side by side, because you're going to see some similarities and differences. So this one, I would say the easiest thing to do on a Delta math angle pair problem is to just use vertical angles to show that they are congruent. So I could immediately say that angle B is 55. And then I can actually add C plus B to 180. So I'm going to say that C plus 55 equals to 180. And then we're just going to subtract that. And we're going to get that C is equal to 125 degrees. Now, on the SAT style problem, what we notice here is that we have fewer numbers and more variables. But the angle pairs are still kind of the same. So where I would start off at is the ones that have the X's in them. We notice that they share the same line. So I'm going to say that X plus 5X minus 12 equals to 180. And I'm just going to combine the X and the 5X to say that 6X minus 12 equals to 180. Now remember to add the 12 on both sides. So we're going to get that 6X is equal to 192. And when we divide that, I'm going to get X is equal to 192 divided by 6. Let me just go to that calculator. So that's 32. And then, of course, we need to find what Y is. So then I'm just going to kind of use a different color. So I could actually say that 32 plus 3y minus 8 equals to 180. So that's going to be 24 plus 3y equals to 180. And we're just going to subtract the 24 on both sides. So I'm going to get 3y equals to 156. And we're just going to divide by 3. And we get that y is equal to 52. Now, of course, another thing that I could do if I wanted to is I could actually say, like, let's see, with 32 degrees, that would make this angle 148. And I could just set that equal as well. That's another way that I could do this. So some of those SAT problems do kind of give you those multiple pathways. Another type of SAT problem are the ones with parallel lines. So the delta math basic problem would be to give you an explicit angle pair. So I can kind of see that these are corresponding angles. So you set them equal. Nice to come up with that game plan. So I'm going to do 9x plus 19. Equals to 10x plus 4. And I'm going to subtract 9x on both sides. So I'm going to get that 19 is equal to x plus 4. And that means that x is equal to 15. And I could always, if I want to check, I could just do like 9 times 15 plus 19. And I could do 10 times 15 plus 4. And I should get 154 on both of them. So that's how I could tell that I did them correctly. All right, this problem, the SAT, one thing you do need to be careful about here, it gives you that the figure above, lines L, M, and N are parallel, and this whole angle is 70. So this means that this angle is 35, and the bisected angle right below it is also 35. And I notice here that I have same side interior angles. It's good to kind of do them 2 at a time. So I'm going to do 35 plus x equals to 180. And I'm going to subtract 35. And that's going to get me to 145. And I'm going to do the same thing for y as well. Now, somebody who's pretty savvy could actually just say, okay, if these angles are congruent to 35s, that means that the x and the y have to be congruent as well. So that means that y has to be 145. So it's just 145 times 2. But if I wanted to solve for y, I could just do 35 plus y equals to 180. And I would get that y is also equal to 145. And I would just do x plus y. So that is 145 plus 145. Which is effectively equal to 290. Giving you an answer choice of D. All right, so these are the problems that I'm going to stop at, but in your class, you are going to have a U-try problems. I want you to kind of try them cold turkey in class without kind of looking at the key, but just a little hint on the U-tries. If you see an angle that is easier to find than the angle that they ask you, so let's say you wanted to do like this problem. So I can kind of see here that we'll call this y. I could say that 108 plus y equals to 180. So y would be 72. And we could actually find what that angle is. Also, things like alternate interiors are pretty nice to find as well. And the more information that you find, the easier that these type of problems are going to get. So it might not be a bad idea to go back and look for those easier angles first and work to the angles that you want to solve.